25 aspirants, so we are just left with few days for the exam, and I can say we are in the final phase of the preparation. So at this point of time we have to do a lot of question practice. So in this video I am going to discuss the top 50 questions from all the chapters, and you can expect similar questions in the exam as well. Okay, so let's get started with the first question from the first chapter of PU2, that is solutions. And let me see the first question here. 25 ml of 0.08 NaCl neutralizes 20 ml of NaOH. The mass of NaOH present in 5 decimeter cube is. Now you know that number of equivalents of HCl will be equal to number of equivalents of NaOH, right? And what's the number of equivalents formula? Normality into volume. So what is the number of equivalents of HCl given? The normality is 0.08 and volume is 25 by 100,000, sorry, and here number of equivalents I have to calculate normality into the volume given here is 20 by 1000. Right, now if I solve this, the normality I'll be getting this 1000 I can cancel. 5 4s are 5 5s are 4 1s are 4 2s are, then I will get 0.1. right, normality is equal to 0.1. so that means what, in 1 liter you have 0.1 moles, right, of NaOH. Then in 5 liter how much I will have, because the question is asked me for 5 decimeter cube, right? So in 5 liter it will be 0.5 moles. Now to convert it into mass, what you have to do, you have to multiply with the molar mass of NaOH. So molar mass of NaOH is 40 grams per mole, right? So if I cancel, I'll get 20 grams. So that is option number A here. Okay, simple and easy question. Let's move to the next question here. Okay, given that the freezing point of benzene is 5.48 degrees Celsius and its Ka value is 5.12 degrees Celsius per molal, what would be the freezing point of a solution containing 20 gram of propane in 400 gram of benzene? So this is a direct formula based question. I think everybody should be able to solve this question. I have this formula, right? Delta TF is equal to Kf into M. Now let me expand the formula. So I have T naught F minus Tf is equal to Kf into molality W2 by M2 into 1000 by W1. Right, now if I want to write down here, T naught F is given to me, benzene is 5.48. So 5.48 minus Tf is equal to Kf, that is 5.12, right? Kf is 5.12 into molality. W2 is how much? 20 grams divided by M2. So it is C3H8, right? 36 plus 8, that is 44. So 44 into 1000 by what is W1, that is 400, right? How much gram of propane is there? Oh, sorry, benzene is there, 400. Now we can solve this. 2 2s are 4, 2 5s are 10, right? I can see that I have 0 0 cancel. So 2 2s are 4, 2 5s are 10. Then I can do 2 1s are 2 10s are, right? 50 by 44 I'll get. So I have 5.48 minus Tf is equal to 5.12 into 50 by 44. Right, so I can just take Tf here and I'll get 5.48 minus 5.12 into 50 by 44. Now if I solve this equation, you will be getting around minus 0.34. So option number A is the correct answer here. Now moving to the next question. A solute X is found to exist as a dimer in water. Okay, a 4 molar solution of X shows a boiling point of 101.04 degrees Celsius. What is the percentage of association of X? For water, the Kb value is given. Now we know that delta Tb is equal to I into Kb into M, right? This is the formula. Now what's the value of delta Tb? Tb can be written as Tb minus T naught B, right? I into Kb into M. Okay, what's the value of Tb? The solution boiling point is 101.04, right? And we know that water boiling point is 100, right? That is equal to I value I have to find out. Kb value is given to me as 0.52 and molality given to me is, what is the molality? 4 molar. right? So now if I subtract this one, I will get 1.04 is equal to I into this one multiplied 4 2s are 8, 4 5s are 10, so 1.08. Right? So now you can see that I value here will be 104 by 108, right? Sorry, I made a mistake. Sorry. This calculation became wrong. Just a minute. Yes, just a minute. Yeah. So it is 4 2s are 8, 4 5s are 20. Right? So now I can see I value will be 1.04 by 2.08. Now can I see if I multiply 2 here, I'll get this one, right? So it is 1 by 2. So I value I got is 1 by 2 or 0.5. Now you have to find the value of alpha, that is degree of association. So alpha value is I minus 1 by 1 by n minus 1. Now I value here is 1 by 2 minus 1, and dimerization, so n value is also 2 minus 1, so this one will give me 1, and 1 into 100 will be 100% association, that is option number B. Next, moving to question number 4. 200 ml of an aqueous solution contains 3.6 gram of glucose and 1.2 gram of urea maintained at a temperature equal to 27 degrees Celsius. What is the osmotic pressure in the atmosphere units? Okay, so you know that osmotic pressure formula is C into R into T, and C is what? Number of moles by volume into R into T. Now here I have two components. What are the components? You have glucose as well as urea. So first let me calculate the number of moles of glucose. Number of moles of glucose will be given mass by molar mass, so 3.6 divided by 180, and number of moles of urea, right? Next is urea, given mass by molar mass, so 1.2 by 60, right? So now you can cancel here 18 2s are 18 10s are, right? I'll get 0.02, and here you will get 12 1s are 12 5s are, okay? And if I just solve this, 1 by 5 is 0.02, this one also, right? So now what is N total? The total number of moles is 0.04. Okay, now we can substitute here all the values. So N total is 0.04 into what is the volume? Volume is 200 ml, right? So 200 into 1000. Okay, now what is the R value? R value is 0.082. Okay, and then temperature is 27 plus 273, that is 300. Okay, now you can solve like this. We will get 0.02, and I can see 0.02 into 3 is 0.06, right? So I have 0.06, and here I have 10 to the power of 3, means I can convert it into 82, right? So 6 2s are 12, 6 8s are 48, plus 1 49. 6 2s are 12, 49, so I will have 4.92, which is your option number D. Okay, moving to the next question number 5, we'll go from electrochemistry here. Let's see now question number 5 here. So you have the assertion and reason based question, and you have to find whether it is correct or wrong, right? So assertion given to me is that when molar conductivity of a strong electrolyte is plotted versus root over of C, a straight line is obtained with an intercept equal to molar conductivity at infinite dilution for the electrolyte and slope equal to -A. All electrolytes of a given type have the same A value. So if you know this formula, lambda m is equal to lambda naught m minus A into root over of C. So y is equal to C minus mx, right? This is the straight line equation. So here you see root over C is in the x-axis and lambda m is in the y-axis, and lambda naught m is the intercept and slope is the -A value, right? This is the equation that we are having. Now at infinite dilution, the strong electrolytes of the same type will have different number of ions due to the incomplete dissociation. Now you see, strong electrolytes always undergo complete dissociation. There is no incomplete dissociation in case of strong electrolytes. So that is why reason is definitely wrong. So assertion is correct, but reason is incorrect. Option number A is the correct answer. Next, what is the quantity of charge required in Faraday units for the reduction of 3.4 moles of Cr2O7 2-? So if you see, Cr2O7 2 minus, okay, gets converted to 2Cr3 plus, okay. So it is plus 6 to plus 3. So reduction takes place with, that means for 1 chromium we need 6 moles of for 1 chromium we need 3 moles of electrons. I have 2 chromiums on both the sides, so 2 into 3 will be 6 moles of electrons, right? So I can say that for reduction of 1 mole of Cr2O7 2 minus, I need 6 moles of electrons. For 3.5 moles, how much I will require? 3.5 into 6, that is 6 5s are 30, 6 is are 18, 19, 20, 21 Faraday. That is option number C here. Okay. Next, moving to question number 7 here. A dry cell consists of a moist paste of NH4Cl and ZnCl2 contained in a zinc casing which encloses a carbon rod surrounded by black MnO2 paste. What is the role of ZnCl2 in it? So if you have remembered the dry cell reaction, the byproduct is ammonia gas, okay, and zinc forms this complex with ammonia so that the ammonia cannot create a pressure there, okay. So the correct answer here is option number A. It prevents the pressure being developed in the cell due to the NH3 gas formation. And how does it prevents the pressure? By forming complex. By forming complex, means zinc forms a complex with ammonia, okay. Next, moving to question number 8. A current of 3 ampere is passed through 750 ml of 0.45 m solution of copper sulfate for 2 hours with a current efficiency of 90%. If the volume of the solution is assumed to remain constant, what would be the final molarity of the copper sulfate solution? This is a very, very good question, a lengthy question, but yes, a very good question. Now see, first you have a copper sulfate solution which is having a molarity of 0.45 m and 750 ml. So from that, first we will calculate the initial concentration of the copper sulfate solution. After that, you electrolyzed it, some amount of copper will get deposited, right? So you will be knowing how much amount of copper deposited, how much was initially present, how much was deposited, we will get. Now if I subtract both of them, I will get the final concentration, okay. So let's proceed. Let's do the calculation. First we will solve the amount of copper or the number of moles of copper deposited, okay. So if you know the formula of Faraday's first law, it tells you molar mass divided by N into 96500 into I into T, right? So if I divide this given mass by molar mass, I'll get number of moles here, right? I'll write out this as number of moles, okay. Number of moles will be equal to 1 by copper N value is 2 divided by 96500, and current is 90% efficient, so 90% of the current, that is 3 ampere, time is 2 hours into 3600. Now if I solve this, okay, number of moles of copper deposited will be 0.1007. You can solve the calculation and check. Now if I take number of moles of copper initially present, how much was initially present? So you know molarity into volume we will get. So what is our molarity? 0.45 and volume is 750 and I have 1000 here, okay. Now if I solve this, I'll get 0.3375. Now this was initially present and this much got deposited. So how much number of moles of copper left? Number of moles of copper left will be how much? 0.3375 minus 0.1007. So I can say 15 minus 7 is 8, 6 minus 0 is 6, 3 minus 0 is 3, 3 minus 1 is 2, 0.2368. Now what is the concentration of copper left now? CuSO4 concentration present now. So number of moles by volume, so this is the number of moles left. Now see, this much was initially present, this much got deposited. Left will be 0.2368 divided by the total volume. Total volume, you can see it is the same. You can see the volume assumed to be constant. So that means the volume is still 7.75 liters. Now if I solve this, I'll get 0.316. That is option number D here. Okay. Now moving to next question number, that is question number 9. Arrange the following redox couples in the increasing order of their reducing strength. Now see, they will reduce others, means itself it will undergo oxidation, right? So itself it will undergo oxidation, and here all the oxidation potentials are given. You can see copper to copper 2 plus oxidation, Ag to Ag plus oxidation, calcium to calcium 2 plus oxidation, chromium to chromium 3 plus is oxidation. So the one which is having higher oxidation potential or highest oxidation potential will be the best reducing agent. So I can see that highest oxidation potential is for option number C, then it will be for option number D. So I will have C, then D, then you have A, and then you have lastly B. That is your option number A given here. Okay, next moving to question number 10 from chemical kinetics. The rate of a gaseous reaction is given by R is equal to K into A into B if the volume of the reaction vessel is suddenly reduced to half of the initial volume. The reaction rate relating to the original rate will be. Now see, if you have, when you have decreased the volume, the concentration increases. Now initial rate was given to me as K into A into B. Right, now what happens, R dash, the volume is reduced to half, that means concentration will become 2A and concentration of B will become 2B. Now R dash by R will give me 4, right? So the answer here will be option number B. The reaction rate relating to the original rate, R dash by R you have to do. Sometimes it may also ask original rate by the new rate. So be very careful which ratio it is being asked in the question. Next, moving to question number 11, the activation energy of the reaction A plus B, A gives you B plus C at a temperature T Kelvin was 0.04606 RT Joule per mole. What is the ratio of the Arrhenius factor to the rate constant for this reaction? This is also a very good question. We have this Arrhenius equation, right? I can substitute like this. Right, now if I take ln on both sides, ln K is equal to ln A minus EA by RT. Right, now if I convert it into log, so I can have 2.303 log R is equal to, log K is equal to 2.303 log A is equal to minus EA by RT. Now if I just want to write in terms of log, I'll get log K is equal to log A minus EA by 2.303 RT. What I have done, I have divided this 2.303 throughout the equation. Then I can take this log K to this side. Log K minus log A will be equal to EA by 2.303 RT. Right, this minus is there, multiply minus on both the sides. So I'll get log A minus log K is equal to EA by 2.303 RT. Right, now log A minus log K, can it be written like this? Log of A by K is equal to EA by 2.303 RT. Right, the question is asking you to find the ratio of Arrhenius factor to the rate constant. Now let's substitute. What is the value of EA given? 0.04606. 0.04606 divided by 2.303. This one is RT, this one is also RT. It will get cancelled. Now if I solve this, I'll get 4606. How many decimal? 1, 2, 3, 4, 5. I'll write 10 to the power of 5. And 2303. 2303, I'll get 10 to the power of 3. Right, so this one will be 2 here. Right, and I will get 2 into 10 to the power of minus 2 or 0.02. Right, 0.02 I will get this value. So I'll just write down the value directly. 1 second. Yes, so I will get the value 0.02. So that is log A by K is equal to 0.02. Okay, now what is A by K value? A by K should be equal to 10 to the power of 0.02. Okay, now see the option. We need a number log of x should be equal to 0.02. You need a number whose log value is 0.02. And I know two things, that log 1 is equal to 0 and log 2 is equal to 0.301. And you should know that log of numbers less than 1 is a negative number. Okay, so I cannot have, I don't want a negative log value, so numbers less than 1 is also incorrect. So if I see here, if you see this is a number less than 1, so this cannot be answer. This is a number less than 1, this cannot be answer. Now you see log 1.5 is coming between 1 and 1 and 2, means exactly somewhere in between. So the answers will also be between 0 to 0.3, right? The answer will be not very less as 0.02. So the correct answer has to be option number D. You can see log 1 is 0, 1.07 will be 0.02. Okay, next moving to question number 12. In the presence of a catalyst at a given temperature 27 degrees Celsius, activation energy of a specific reaction is reduced by 100 joules. What is the ratio between the rate constants for the catalyzed and uncatalyzed reaction? Okay, now you see for catalyzed reaction I can write K2 equal to A into e to the power of minus E2 by RT. Right, and K1 is equal to A into e to the power of minus E1 by RT. Now what is the value of K2 by K1? That is equal to e to the power of minus E2 by RT divided by e to the power of minus E1 by RT. So I will get E into E1 minus E2 divided by RT. I'll get e to the power of 1000, sorry, E1 by E2 is how much? Just a minute. Okay, so what is the difference between the activation energies? The difference is 100 joules, right? 100 divided by R into T. Now if I take log on both the sides, right? So I'll get log K2 by K1 is equal to 100 by 2.303 RT, right? Now if I solve 100 divided by 2.303 into R is 19.1, and temperature is given how much? 27, means almost 300, right? So now I'll get 19.1, I'll take it as just 19, so I'll get 100 by 5700, I can cancel, right? So I'll get 1 by 57. Now 1 by 57, if you solve it, it will be equal to 0.02, something nearly equal to 0.017 or 02. So I have to find a number whose log value is 0.02. Now just previous question we have solved that 1.04 value will be equal to 0.02. So option number D here. Okay, now moving to the next question, which one of the following is an example of pseudo first order reactions? So we know that acid hydrolysis is a pseudo first order reaction, alkali hydrolysis is not there. Okay, acid hydrolysis of ester is a pseudo first order reaction. Okay, next we'll go to D and F block questions. When SO2 is passed through acidified K2Cr2O7, what happens? Now see, when K2Cr2O7 is passed through SO2, okay, SO2 plus K2Cr2O7. So Cr gets reduced to +3 and SO2 gets oxidized to SO4 2-. So chromium sulfate is formed, that is this one, green color compound, option number D here. Okay, next, the first ionization energy of the elements of the first transition series. So as we move along the period from titanium to copper, the effective nuclear charge increases, so the ionization energy increases with the increase in atomic number, so option number A. Okay, does not decrease, do not show any change, that is also not there. It does not first increase and then decrease, that is in other properties, but ionization enthalpy increases along the period. Next, lanthanoids and actinoids resemble in the electronic configuration. You know, both of them have this electronic configuration of n-2, 1 to 14, n-1 D, right, n-D, 1 0 to 1 and ns2, right? They both have this similar configuration. Next, in the chromate ion, dichromate ion Cr2O7 2-. So if you see, it is like this, Cr2O7 2- is like this, right? Now you see here these bonds, okay, these bonds are under resonance, right? If these bonds are under resonance, then we will have like CRO bond will be always equal. These CRO bond and these CRO bonds are equal, but these CRO bond where there is no resonance, these are different. So I have total 6 equivalent bonds, so option number B. Okay, next we have question number 18 from coordination chemistry. The 2 isomers are given and what type of isomers they are. So you can see this is of MA3B3 type. You will have facial and meridional isomers, so option number A. And the first one here, okay, the first one here, this is your facial, and this one, when all the 3 are present in one plane, this is your meridional. Okay. Next, question number 19, the magnitude of the magnetic moment of NiCl4 2-. So Ni, if you see here, it is in +2 oxidation state. +2 oxidation state means 3D8. Now if I have 3D8 configuration, okay, so you can see 1, 2, 3, 4, 5, 6, 7, 8. 2 unpaired electrons are there. So for 2 unpaired electrons, the magnetic moment will be 2.82. If you remember the formula, it is root over of n into n plus 2. So I have root over of 2 into 2 plus 2, that is root over of 8. Okay. Next question is the coordination number and the oxidation number of X in the following compound is. So if I first found the coordination number, here there are 5 ammonia and 1 sulfate. So it is forming total 6 bonds. So the coordination number will be 6. So I can eliminate these 2 options. Now talking about the oxidation number, let this one be X. Sulfate ligand charge is -2. This is a neutral ligand. That, and then chlorine is equal to -1 is equal to 0. So X will be equal to +3, option number A here. Next we have question number 21, the formula of the complex potassium trichloridoethylene platinate 2 is. So first of all, you can see that we have trichlorido, right? So I should have 3 chlorido, that is all present in all the options. Here there is diplatinum, 2 platinum is given, I can eliminate this option. Next I have trichloridoethylene, ethylene means there is only 1 ethylene group present, right? Here there are 3 ethylene group present, so I can eliminate this option also. Now this can be the answer or this can be the answer. What next I can check? The oxidation state of platinum. Now here if I see, okay, potassium is +1 for option number A. Potassium is +1, platinum is X, okay, chlorine is -3, C2H4 is neutral, so that will equal to 0, and X will be equal to 1 minus 3 is -2, that is +2. Now if I see option number C, here I have +4 and then I have X, okay, and then this I have -3 and this is 0 equal to 0. So X here will be equal to -1, but oxidation state is given +2, so this cannot be the answer. A will be the correct answer. Right. Next, moving to question number 22. So organic chemistry, I have not given chapter wise because organic chemistry, you know, it is a mixture of all the chapters. So we have taken together all the organic chemistry questions. Okay. The elimination of bromine from 2-bromobutane results in the formation of. So if I have 2-bromobutane, you know, Sedzeff product will be the major product. So the alpha beta elimination will take place and we'll get a product here, that is but2-ene will be formed predominantly. That will be the major product formed. Next, coming to question number 23. In the given reaction Zn and ether. Now Zn and ether, what does that do? It helps in the production of the radical. So we get a radical here and a radical here. The chlorines are converted to radicals. Now these two can form a bond like this and we will get option A as the correct answer. Okay, next moving to question number 24. An alkyl, just a minute, did I miss any question? No. Okay, next, an alkyl chloride produces a single alkene on reaction with sodium ethoxide and ethanol. Okay, one single alkene you are getting. The alkene further undergoes hydrogenation to yield 2-methyl butane. Identify the alkyl chloride from amongst the following. Okay, so first we have NeRx. Okay, we have to find this alkyl chloride. It gives us single alkene on reaction with sodium. So once you react with this one, we get a single alkene here. When I'm telling that it is a single alkene, means there was possibility of formation of only one product. It is not any major minor product is not there. There was only one possible product, and that one possible product is formed. Now whenever such question comes, there is only one possible product, you have to know that if the halogen is present in the between carbons, in the middle carbons, then you have major and minor product possibility. But if the halogen is present on the terminal carbon, we will have only one product. So when I'm saying that only single alkene was formed, that is a clear indication that the halide group is present on the terminal carbon or on the last carbon. Clear? So from this, what hint I got? That halogen is present on the terminal carbon. I hope this is clear, because if it is present in the between, you can have two products, Seytzef and Hoffman, both products are possible. Okay, now after this, when I treated this alkene with hydrogenation, means just you added hydrogen, you got 2-methyl butane. So I have the product like this, 2-methyl butane. So my assumption here is this alkene must be formed here. Okay, if this alkene is formed here, and then if I do hydrolysis, I'll get this one, and for the alkene to form here, I can have X here. So definitely it is something 2-methyl and some haloalkane, I'll get like this. So let me see the options here. The first one is saying Cl CH2, then I have C CH3 whole to CH3. No, this is not the answer. Next one, let's see. I have Cl, then I have CH2, I have CH, there is no branching here, so this also is not the answer. Next I have Cl, then I have CH2, then I have CH, yes, CH3, then I have CH2 and CH3. Yes, this has to be the answer, that is option number C. Now if you see the option number C and D structure, if I do, okay, I will have Cl, CH2, CH, CH3, okay, and then I have CH2 and then CH3. This is option number C, and option number D here is CH3 CCl, okay, and then you have CH3, and then you have CH2 CH3, right? Now if you see here, again there is a single alkene product possibility, but if you see here, I can get an alkene here as well, right? So this is not the answer. Single alkene means here only there will be a single alkene production, so option number C is the correct answer. Next, moving to question number 25, which of the following is most readily reactive with Lucas reagent? We know tertiary alcohols are highly reactive, so option number C here. Next question, 1-phenile ethanol can be prepared by the reaction of the benzaldehyde with. So we want to prepare we have to react benzaldehyde with something to get what? 1-phenyle to produce 1-phenyle ethanol, right? So I have 1-phenyle ethanol. Okay, so what you have to do, you have to simply add a CH3 group here, right? So you can add methyl iodide and magnesium, so that will be a methyl magnesium iodide will be your Grignard reagent, then it can attack here, so option number C is the correct answer. Next, here is a question of H plus reduction. So whenever you know the phenol, this bond cannot break, so the bond will break here. So one of the major product has to be phenol. So there is only one option with like this. So option number A is the correct answer. Okay. So this brings O minus and this brings H plus, and then it takes another H plus, and we get a compound here, and this one gets converted to phenol ring. Okay, next, mark the correct order of acidic strength. So if you know acidic strength, higher the electron, if there is an electron withdrawing group, that will increase the acidity. So definitely 2 is having NO2 group, so it will have the highest acidity. So that is option number B, only 1 is there. Then fourth one will be there at the meta position. Then first, because this OCH3 and OCH3 are electron donating groups, so after that first, then we have 3, and lastly I have 5, so option number B here. Next, coming to reaction based question, CH3CHO reacts with CH3 MgBr. So first of all, I'll get this one. C, double bond OH was there, it will attack, so I will get OH and CH3. Okay, now this is A. Now if I do H2SO4, what will happen? There will be, this is A. If I react with H2SO4, there will be dehydration and I will get compound like this. Okay, so that is option number B. Now if I do hydroboration oxidation, right, hydroboration oxidation will add water like this. Okay, so what is the relation between A and C? Okay, A and C. So this is a propane 2OL and this is propane 1OL, right? So these are your positional isomers. So option number B here. Next, which of the following orders is not the correct for the decreasing order of acidic strength, which is not correct? Okay, let us see the first one. If you see, chlorine is present on the first carbon here, chlorine is present on the second carbon, then here it is present on the third carbon, and here it is not present at all. So this is a correct order. Okay, you know, inductive effect decreases as we move far away, right? So that is why this is the correct order. Next, I have iodine, bromine, chlorine and fluorine. This is definitely wrong order. Why? Because fluorine is more electronegative, so it can better stabilize the conjugate base. So fluorine should be highly acidic. So that is why option B is the correct answer. Let's see the other options. Here you can see 3 chlorines are there, so it will stabilize better. 2 chlorine, 1 chlorine, no chlorine. So this is also correct order. Here you can see formic acid, then I have CH3, C2H5 and CH3 2. So this is also correct because as the R group increases, the stability of the conjugate base decreases. Now moving to the next question, correct order of acidity. So first definitely we have acids, then the order is water, then alcohol and then ethyne. So option number C here. Next question 32, you have to find the product for this one. So if you see dilute NaOH, right, that is what? That is your, I can say, aldol condensation, right? So I can have a product C, HC double bond OH. I have already taught you how to write the aldol condensation product, right? So what you have to do, you have to connect the alpha carbon with the carbonyl carbon, and then what you have to do, and then you have to remove this one bond. Okay, now you have to remove one hydrogen as well, right? So if you remove one hydrogen, it will become CH2 and this will become OH. After that you have to remove OH and H and you will get a double bond here, right? So I will get OH, I will remove, I'll remove OH and I will remove H. So what will be the product here? CH2 double bond CH, C double bond OH. Now if you treat it with HCN, okay, now if you treat it with HCN, we will get OH and CN, CH2 double bond CH, COH and then CN and then H. Now if you hydrolyze it, we will get converted to COOH. That is your option number A here. Okay. Let us see the next question here. Find the product of the given reaction. Okay, so you have this one and then this one. So you know the addition of ammonia and its derivative. So what basically will happen? So if you remember any ammonia derivative reaction, okay, if I have like this H2N and then Z, so what will happen? H2O will be removed and I will have N and Z, right? So the same thing here. Here we have this phenol benzene ring, okay, and then I have this CH3, okay, double bond, and then I have N is there, okay, and then I have CH2 and CH3. Okay, so where I'll get that one? I think that is your option number B here. Okay, next moving to question number from some basic concepts of chemistry. So we are now moving to PU1 chapters. Okay, 5.8 gram of NaCl is dissolved in 1 liter of pure water. The number of ions in 1 ml of the solution is. Okay, so if you remember, first of all, let me calculate the molarity. What is the molarity? Given mass, right, by molar mass, right, into 1000 by volume. Yes, by volume. So volume is already 1 liter, so let me just keep it as 1 liter, right? So volume is 1 liter. So now if I have given mass is 5.85 and the molar mass of NaCl is 58.5. So how will be that much? It will become 0.1, right, 100 and by then 10, 0.1 moles, right? So I can say that in 1000 ml, okay, or in 1000 ml or in 1 liter, we have 10 to the power of minus 1 moles of what? NaCl. But that means in 1 ml, how much it will be? 10 to the power of minus 1 by 10 to the power of 3, or I can say 10 to the power of minus 4 moles, right? Now in these many moles, how many atoms are there? The question is asking number of ions. So in 1 mole of NaCl there are 2 ions, right? So I will have total ions will be, see, in 1 mole I have 6.022 into 10 to the power of 23 into, in 1 NaCl there are 2 ions, right? These many ions are present in 1 mole. In this many moles it will become 10 to the power of minus 4. So I can 2 2s are 4, 4, 0, 12 into 10 to the power of minus 19, sorry, plus 19. So if I take 1.2004 into 10 to the power of 20. Let us see the next question here. An organic compound on analysis gave carbon 54.2, H 9.2% by mass. Its empirical formula will be, okay. So if you calculate the empirical formula here, carbon, hydrogen and oxygen. So we have carbon 54.2, hydrogen 9.2. Now if I add both of them, how much I'll get? 63.4, right? 2 plus 2, 4, 9 plus 4, 13, 63.4. So 100.00 minus 63.4. So I will have I'll have 36.6, right? Yes, 36.6% is oxygen. Now what will be the number of moles? 54.2 divided by 12, right? 54.2 divided by 12, then I'll have 9.2 divided by 1 and 36.6 divided by 16. So if I solve this one, I'll get 12 4s is 48, right? So 4.1 something I will get, okay, or 54, let me just divide 54.2 divided by 12. 12 4s is 48, right? So how much is left? 62 I'll get. So 4.5, 12 5s is 62. So I'll take 4.5 something. This will give me 9.2 and 36.6 divided by 16. So if I solve this one second, okay, 36.6 divided by 16. So I have 36.6 divided by 16. So 16 2s are 32. 46, 16 3s is 48, 16 2s is again 32. So I'll get something around 2.2. Now if I just divide them, each of them, I'll get 2.2 by 2 is 1. 2.2 into 4 is how much? 4 2s are 8.8. So I'll get something near to equal to 4, and 2.2 into 2 is 4. So C2H4O I will get option number D here. Okay, let us see the next question here. What will be the mass of a particle if the uncertainty in its position is 10 to the power of minus 8 meter and the velocity is 5.26 into 10 to the power of minus 25 meter second inverse? So if you know Heisenberg uncertainty principle, the formula is delta x into delta p greater than h by 4 pi. Now we have delta x into m into delta v greater than or equal to h by 4 pi. Now if I have here, I have to calculate what? You have to calculate the mass. So I can write mass will be equal to h by 4 pi into delta x into delta v, right? So let's just substitute the values. 6.63 into 10 to the power of minus 34. Then I have here 4 into 3.14 into, what is the delta x value? 10 to the power of minus 8, right? And here I have This one is around delta V, right? What is the value of delta V? 5.26 into 10 to the power of minus 25. Okay. Now if I solve this, the values, if I solve this, I'll be able to calculate the mass, and that will be equal to option number A, that is 0.01 kg. Okay. Next, you can see, if I just want to do a rough calculation, so let me just take it as 5 4s are 20, 23s are 60, right? So I'll get 6 something, I can cancel these two. Next I have 25 plus 8 is 33, so 33 goes up, it will become plus 33, so minus 30, so this has become 1 into 10 to the power of minus 1, that will give me 0.01, 10 to the power of minus 2 I'll get, right? So I can say like this, I will just do rough calculation, 6 by 60, okay, then I have 10 to the power of minus 1 here, so this one will give me 10 to the power of minus 2, so 0.01. Okay, you can do a rough calculation, you will be getting the answer around this one. Next, the number of radial nodes and angular nodes for d orbital can be represented as. So if you know, radial nodes is equal to n minus l minus 1. So for d orbital it is 2, right? So the L value is 2. So R value will be n minus 2 minus 1, right? So that is equal to n minus 3. And the angular nodes will be equal to 2. So that is 2. And the total nodes here will be n minus 1. N minus 1. So I can have here n minus 3 radial nodes plus 2 angular nodes plus n minus l minus 1 total nodes, no. n minus 3 radial nodes, 2 angular nodes, and n minus 1 total nodes, that is the correct relation given here. Next, we'll go to chemical periodicity. Elements X, Y and Z have the atomic number 19, 37 and 55, okay, respectively. Which of the following statements about them is correct? Now if you see, the gap between 19 and 37 is 18, right, and here also the gap is 18, so that means these elements, right, that is your X, Y and Z, belong to the same group. Okay, they belong to the same group. So if they are belonging to the same group, then what about the ionization enthalpy? Ionization enthalpy will decrease down the group, means X will have highest ionization enthalpy, then Y and then Z, right? It will decrease along the group. So Y ionization enthalpy will between X and Z. The first point that is given, their ionization potential would increase with the increased atomic number. Is this a true statement? Obviously not. Why? Because now if I see the first statement, their ionization potential would increase with the increase in atomic number. Now you see, down the group the atomic number is increasing but the ionization potential is decreasing, so this is the wrong one. Then Y would have an ionization potential between X and Z. Yes, that is correct. So option number B can be the correct. Z will have the highest? No, Z will have the lowest. Y would have the highest? No, X will have the highest, right? So B is the correct statement. Next, the increasing order of the first ionization enthalpy of boron. Okay, then we have after boron, that is carbon is there. Okay, so I will be mentioning all the elements so that we can know their placements in the periodic table. Oxygen, sulfur and then fluorine, right? So you have been given with these elements. I'm just circling which elements are asked. So ionization enthalpy. So down the group the ionization enthalpy decreases. So phosphorus and sulfur will have less ionization enthalpy, right? And along the period the ionization enthalpy increases. So definitely fluorine will have the highest ionization enthalpy, and I can eliminate this option, right? After that, if I compare sulfur and phosphorus, sulfur will have more than phosphorus. Is it correct? No. If you remember, nitrogen have, or this group 15 have exactly half filled orbitals, so their ionization enthalpy is more than oxygen and sulfur. So before sulfur, phosphorus should come, right? So I have one option here and I have one option here, and lastly we will have boron. So option number D is the correct answer here. Next, we'll move to question number 40 in chemical bonding. Consider the following statements and you have to find the which statement is correct here. Okay, correct statement we have to find out. Now N2 plus, if I see N2 plus, it has 13, number of electrons is 13, so bond order is 2.5, right? And what is the bond order in N2? The bond order of N2 is equal to 3. So now if I talk about the bond length of N2 plus, since it is having more less bond length, less bond order, it will have more bond length than N2, simple N2, right? If you remember, bond order, right, is inversely proportional to bond length. So here bond order is less, so bond length will be more. So bond length of N2 plus is 0.02 angstrom greater than N2. That is a correct statement here. Next, if I talk about NO plus and NO. Now NO plus will have how many electron? 7 plus oxygen is 8, 15 minus 1, 14. So NO is having 14 electrons. 14 electrons means bond order is 3, and NO plus, and NO will have 7 plus 8, 15. 15 means its bond order is 2.5. So I can say that bond length of NO will be greater than the bond length of NO plus, right? Here bond length in NO plus is 0.09 angstrom less than that of NO. That is also correct here. Next, if I talk about O2 2 minus has a shorter bond length than O2. Now if you see O2 2 minus has 8 plus 8, 16, 17, 18 electrons. O2 2 minus has 18 electrons and bond order is 1, and O2 has 16 electrons and the bond order is 2, right? So that means here O2 2 minus should have a longer bond length because its bond order is less, but it is given has a shorter bond length. So that is why this is wrong. So I have 1 and 2 only correct statements. So option number C here. Next, moving to question number 41, the hybridization of ethyne, ethene and ethane. Ethyne is what we call sp hybridized, right? So sp, ethane is sp3. So I can have these two options. So I'll first erase, wait just a minute. Okay, so yeah, ethyne is this triple bonded, so it is sp. Then if I have ethene, okay, ethene is 1 2 3 sp2, and if I have ethane, that will be sp3, right? So answer will be sp, sp2 and sp3. So option number 41. Next, coming to 42 question. So here this question is from thermodynamics, very important question. You have been given with the delta H of formation of CO2, H2O and C3H6, and the delta H of isomerization of cyclopropane to propane is given -33. What is the standard enthalpy of combustion of cyclopropane? Okay, so if I write the combustion reaction of cyclopropane, okay, so it is C3H6 plus O2 gives me CO2 plus H2O, right? This is the combustion reaction for propane. Now how to balance this one? So I will have 3C and I have 6, so I have here 3, so 6 hydrogen, 3 plus 2 6 plus 3 9, so I can have here 9/2 oxygen. Okay, now it is balanced. Now if I want to write the delta H of this reaction will be equal to enthalpy of products minus enthalpy of reactants. So I will have 3 times the enthalpy of formation of CO2 plus 3 times the enthalpy of formation of water, right? That is enthalpy of products minus I have the enthalpy of formation of C3H6, which is your cyclopropane here. Okay, it is not propene, it is cyclopropane. Now how to calculate the enthalpy of formation of cyclopropane? So remember, enthalpy of formation of cyclopropane, okay, that will be equal to enthalpy of formation of propene. Okay, first propene will form plus then enthalpy of formation of isomerization of propene to cyclopropane. So now I can write here enthalpy of formation of propene is how much? 20.6. Okay, now see, propene to cyclopropane. The cyclopropane to propane is minus 33, but if I want propene to cyclopropane, it will become negative of this one, so that is 33.6. I will get 53 6 plus 6, just a minute, not 33.6, only 33, right? So I will get 53.6, right? I'll get 53.6 is the enthalpy of formation of cyclopropane. Now if I want to write down the values here, so let me just substitute 3 into, what is the enthalpy of formation of carbon dioxide? Minus 393.5, right? Plus 3 times of enthalpy of formation of water, minus 286. Okay, then we have minus cyclopropane enthalpy is 53.6. Okay, clear? Now if I want to solve this, it will be 3 5s are 15, 3 3s are 9 plus 1 10, 3 9s are 27 plus 1 28, 3 3s are 9 10 11, right? So if I have done correct calculation, I'll get this one. Then 3 6s are 18, 3 3s are 24 plus 1 25, 3 2s are 6 7 8, right? Yes, then we have minus 53.6. Now let us add all these data. Okay, so if I just solve this, I will get 5 plus 6 11, I have 1. Then so just let me calculate 1180.5 plus 858. Okay, then I have 53.6. Okay, 8 I have 12 here, 18 plus 1 19, 8 9 10 plus 1, I'll get 20, right? 92.1. So somewhere around 2092. So that is why option number A is the correct answer here. Okay, A is the correct answer, right? Now let's see next question, that is question number 43. 5 moles of an ideal gas at 3 atm pressure and 27 degrees Celsius is compressed isothermally to half its volume by application of an external pressure of 3.5 atm. What is the amount of work done on the gas? So if you remember the work done formula, okay, what is work done formula? Minus P external into V2 minus V1. Right, this is the formula that we have for the work done. Now we can see that for calculating the initial volume, we know that the final volume half of the initial volume, right? Now if I want to calculate the initial volume, I have this formula PV equal to nRT. So from that I can calculate nRT by P, right? N is equal to 5, right? R is equal to 0.082, right? 0.082. Then T is equal to 300 Kelvin. Okay, next pressure will be equal to how much? Pressure given is 3 atm. Okay, clear? Okay, now if I solve this, this one will give me 100. Okay, and next if I calculate this one, this is around 8.2. right? So 5 2s are 10, 5 8s are 40 plus 1 41. Okay, 5 I'll get 500. So 8.2, 5 2s are 10, 541. So the final initial volume was 41 and the final volume will be half of 41, right? So I have this formula 3.5. This one is minus external pressure is how much? 3.5. Okay, 3.5. V2 is how much? 41 by 2, right? Minus 41. So 41 by 2 will be how much? I can just calculate here. 41 by 2 will be equal to 20.5, right? So 41 minus 20.5. Okay, so 10 minus 5 is 5, 0, 2. I'll get, okay, so 20.5 I'll get here. 3.5 into 20.5. So now this is what? This is your external, this is the work done that I am getting. So this one will be negative number, so negative will become a positive number. Now if I solve this 205 into 3.5, okay, eraser will, I'll just check 1 minute. Yeah, so you can just multiply this one, 205 into 35, okay. So I have 5 5s are 25, 0 2, 5 2s are 10, then I have 3 5s are 15, 1 6, okay, 5 7 1 7, 7175 I'll get, so that is equal to almost 71.75. Now this is liter ATM, right? This liter ATM has to be converted into joules, right? So you will get around 7,000 into, you have to multiply with 101.3, right? Now if I multiply, it will come almost 100, right? You can take it around 7175 something should come. So the nearest answer here is option number B, that is, this is the correct answer. Now moving to next question number 44 from equilibrium. At 700 Kelvin, the equilibrium constant value for the formation of HI from H2I2 is 49. So the equilibrium value for this reaction, that is the formation of HI from H2I2, right? So this equilibrium value is how much? 49. If 0.7 mole of HI is present at equilibrium, HI present at equilibrium is 0.7 mole, what will be the concentrations of H2 and I2 gases if we initially started with HI and allowed the reaction to reach equilibrium at the same temperature? So if you are initially starting with HI, okay, then what will be the reaction if you are starting with HI? The reaction will be like this, right? So this is the opposite of this reaction. So what will be the K value for this reaction? This reaction K value was 49. If I have reversed the reaction, this reaction K value will be 1 by 49, okay? And so I can say that K equilibrium, just a minute, yes. So K equilibrium is equal to H2 into I2 divided by HI square. Okay, now H2 value is how much? H2 value is 0.7. No, I have to find the H2 and I2 value, right? So let this be cancelled. Okay, so I have here X, just a minute. Yeah, I have here X and this value is X, and then HI square. HI square is how much? That is 0.7, right? This is equal to 1 by 49. Okay, now I can write down here X square is equal to how much? 0.7 square divided by 49. Now X square will be equal to 0.7 by 7 square. Okay, so now I have here X value equal to 0.1. Okay, so you can see all the options are not exactly correct, but I can find the most appropriate answer as option number A here. Next we'll go to question number 46. What volume of 0.2 m acetic acid is to be added to 100 ml of 0.4 m sodium acetate so that a buffer solution of pH equal to 4.94 is obtained? Okay, so now if you know that we have, how can I solve this one? We have this formula. See, I can say we are taking acetic acid. Okay, acetic acid, 1 second, sorry, yeah, so what we have taken, acetic acid plus sodium acetate, right? So CH3COONA. So if you remember, this is an acidic buffer. So for acidic buffer, what is the formula of pH? So for acidic buffer, the pH formula is equal to pKa, right, plus log of salt concentration by acid concentration. Okay, this is the value we have formula. Now pH here will give me, pH will be equal to Okay, now let me assume you have to find that what the volume of acetic acid. Acetic acid is 0.2 molar, okay, to be added to 100 ml of 0.4. So I have 100 ml of this one and 0.4 molar sodium acetate, okay. So that a buffer solution of pH equal to 4.94 is obtained and pKa value is also given to you. So now if I see, let this volume be V. I don't know, right? Let it be V. So molarity is there, volume is there. So concentration of this one will be what? 0.2 V. And the concentration of this one, let it be V liters, okay. So 0.2 into V, and this one, if it is 0.1 liter, so that means 0.4 into 0.1, this one will be 0.04, okay. So I can substitute here, pH value is 4.94 and I have pKa value as 4.76 plus log of salt concentration is how much? 0.04, okay, and acid concentration is 0.2 V. Okay, so now we have to just solve and this find the value of this V. Now what I can do, I can subtract this. 14 minus 6 is 8, 8 minus 7 is 1, so I'll get, I think, 0.18, okay, that is equal to log of I can say how much I will get. I can cancel this one as 2 into 0.1 volume and 2 into 0.02, right? So if I just write it properly, it will become 2 by 100 into 1 by 1 V by 10, okay. So I have how much? 2 by 10 V, right? This is log of how much? Log of 2 by 10 V I got. Now if I take anti-log of this one, okay, you will get it around 1.04, okay. 1.04 is equal to 2 by 10 V, okay. Now V will be equal to 2 by 10.4, okay. This is in liter. Now if I want to solve it, I want to convert it into ml because the options are in ml, so I can just multiply 1000 here. So 20,000 by 104 if I do 104, okay. So I'll take, obviously first will be 104, right. So I will have 96, right, then 960 if I am having. So I can say I can go up to now if you see, if I take anti-log on both sides, so I will get 10 to the power of 0.18 is equal to 2 by 10 V, right. Now if I solve from here, what this is 1.51 equal to 2 by 10 V, okay. Now how I'm guessing it is around 1.51. Now if you see, log 1 is equal to 0, right, and log 2 will be equal to 0.3, right, and this is 1.8, means somewhere in between this one, right. 1.5 will be between 1 and 3, 0.1 and 0.3. So in that way I am thinking is can be near to log 1.51, okay. So if I solve this now for V, I'll get 132.1, which is your option number A here, okay. Next, question number 47, redox reaction. Let us see the next question here. In the redox reaction between Cr2O7 2 minus H plus means an acidic medium and sulfide ions, what is the number of moles of electrons involved in producing 3 moles of oxidized product? Okay, so first of all you have to write the balance equation for this one. So if I have Cr2O7 2 minus, okay, that gets converted to Cr3 plus, right, it is a reduction process, plus 6 to plus 3, so total there is a gain of 6 moles of electrons, and if I want to balance here, I will have 7 water, okay, then I have 14 H plus. Okay, this is the balanced reaction. And next I have sulfite ion, so SO3 2 minus to SO4 2 minus, right. So here it is plus 4 to plus 6 oxidation, so I will have loss of 2 electrons here. Next, if I want to balance it, what I can do, I will add 1 oxygen H2O here, right, and with that I will also add 2 H plus here, right. Now we have to balance the number of electrons, so we can multiply the whole equation with 3. So I have 3 H2O, 3 SO3, 3 SO4, and I have 6 electrons and 6 H plus, right. Now you can add both the reactions and you can cancel the common terms if any. So you can see 6 electrons can be cancelled with 6 electrons. Next I have 14 H plus and 6 H plus, so I will get 8. So first I can write Cr2O7 2 minus plus 14 H plus and then 6 H plus, so that will give me 8 H plus, right. Then I have 3 SO3 2 minus, okay, and that will give me 2 Cr3 plus, okay. 7 water plus 3 water, I will have 4 water, okay. Then I have 3 SO4 2 minus, okay. I think that is done. Cr2, then I have 14 minus 6, I have 8 hydrogen, then I have 3 SO3 2 minus, then I have 2 Cr3 plus, 7 minus 3, 4 H2O is there, and then 3 SO4. So what I can say, that for getting 3 moles of oxidized product, we need 6 moles of electron, right. So the correct answer here will be option number D. Next, moving to question number 40, I think this is question number 48, okay. In the estimation of element X in an organic compound, 0.8 gram of organic compound X was heated with fuming HNO3 and the cool product was treated with barium chloride. The mass of barium sulfate precipitate was 1.2 gram. So mass of barium sulfate is how much? Just a minute. Okay, mass of barium sulfate is 1.2 grams. Next, what is the percentage of element X and what is the formula of the violet colored compound formed? So we have to find the element X. So you can see from the question that the element X is nothing but sulfur, and if I want to find the percentage of sulfur, okay, so you know sulfur mass is 32 divided by 233, right, into the mass of barium sulfate produced divided by the total mass of the organic compound, that is 0.8 into 100. Now if you solve this, okay, I can say 4 2s are 8, 4 3s are 12, and then 2 1 2 16s are, if you just solve it, you will get around 20.6, okay, and then the compound that is formed is Na4FeCN5NOS, that is your option number B is the correct answer. Next question, in Zeldal method, the ammonia form 8 gram of food neutralizes 60 centimeter cube of 0.1 N acid. The percentage of nitrogen. So by Zeldal method, if you want to calculate the percentage of nitrogen, it is 14 into N, that is normality, into volume by W into 100, right. So I have 14 here, okay. What is the normality given to me? Normality is 0.1. right. Volume is how much? Volume you can say 60, right, divided by what is the mass given? 8, and then 8, and then I have 100. Clear? So now let us solve it. 2 4s are 8, 2 7s are 14, 4 1s are 4, 4 15s are 60, right. 7 5s are is 105. Right, 7 5s is 105, and I have here 00, and then I have 0.1. Okay, one more thing I missed. This is in ml, right? So you have to again convert it into liter. So -3. So you will get 1.05. That is option number A here. Okay, just a minute. That is option number A. Now moving to question number 40. Yes, question number 50 here. An organic compound weighing 0.15 gram gave on Carrier's method 0.12 gram of AgBr. Okay, so what is the mass of AgBr produced? AgBr produced is 0.12 gram. And the mass of organic compound we have is how much? 0.15 gram. Okay, next we have what? The percentage of bromine in the compound will be close to percentage of bromine. So if I have the percentage of bromine, that will be equal to mass of AgBr. In that we have, so the formula is 80 by 188 into mass of AgBr, right, divided by mass of organic compound into 100. So just substitute this value, 80 by 188 into, what is the mass of AgBr we have got, 0.12 divided by 0.15 into 100. Okay, I have this one, then yes, then I have 4 4s are 16, 16 to 47, right? So if I solve this 16 by 47 into 100, you will get 34.1%. That is option number B here. Next question, the compound nitrogen detection in an organic compound is carried by Lazine test, and the blue color is formed due to your Fe4 FeCN6 that is the compound that is formed. So option number C here. Okay, so please remember this one. Yes, so that's all in this class, students. We have solved almost 50 questions. Most important, do revise these questions and practice similar type of questions. You will be getting such questions in your exam. Okay, that's all in this video, and thank you for watching, and do not forget to subscribe the channel, and all the best for your COMEDK 2025 examination.